So last weekend I was really bored and decided to make this at-home basketball hoop out of a laundry basket and hang it up at the official NBA height of 3 meters and 10 centimeters. Then I got the sponge basketball that weighs the same as an official basketball. So I put on my hoop shoes and decided to shoot around for a little bit. After a while I realized that I should probably get started on my physics video analysis assignment. But then it hit me. I can just analyze a video of me shooting a free throw. So I measured the foul line about 4.5 meters away from the hoop. Then I just shot the ball how I normally would. With some help, I was able to measure my exact released height of 2.06 meters. Then, using the formula velocity final squared equals velocity initial squared plus 2AD, and assuming that velocity final is 0, I was able to get the velocity for the x and the y, leading me to use the Pythagorean theorem to get the velocity in the direction of the ball. Then using cosine, I measured the launch angle for the ball, which was around 64 degrees, which made sense to me why it was such a high number, because I wasn't jumping on my shot and I have a low release point, meaning I need more of an arc to get the ball in the hoop, just like the great shooters such as Steph Curry. But I wasn't done there. I wanted to know how much energy and power it took for me to shoot this free throw. So, first, I calculated the applied force on the ball using the mass and the acceleration. Using this, I was able to get the applied force in the vertical and in the horizontal. Using these two forces, I was able to calculate the total applied force on the ball, which was 1.3279 newtons, forward 64.3101 degrees up. Lastly, I calculated the work and the power. For the work, I used force delta D, which gave me around 6 joules, and for the power, I used work over delta T, which gave me around 3.1186 watts. And now just to wrap up, if I want to keep making my free throws, I should be shooting with 3 watts of power, around 6 joules of energy, 1.3 newtons of force, at 10.4 meters per second, and at a launch angle of 64.3 degrees approximately.